Welcome, curious minds. Imagine two materials made of the same element, yet exhibiting extraordinary differences. Today we journey into the inner workings of atoms to explore isotopes and allotropes. In these seemingly small variations lie vast implications for chemistry and our material world. Let's begin with the very building blocks of matter. Atoms are minuscule units consisting of protons, neutrons, and electrons. These components form every substance in the universe, connecting science with everyday life. Each atom carries its own story, influencing chemical behavior with subtle shifts in structure. Tiny differences in atomic makeup can lead to tremendous diversity. Now, let us dive into isotopes. Isotopes are variants of a chemical element that share identical proton counts but differ in their neutron numbers, creating distinct mass numbers. Carbon, a cornerstone element in both organic life and materials science, boasts notable isotopes, carbon-12 and carbon-14. Carbon-12 contains 6 protons and 6 neutrons, making it stable and abundant on Earth. In contrast, carbon-14 holds 2 extra neutrons and is radioactive, serving as a powerful tool for radiocarbon dating. These variations exemplify how small atomic differences generate significant scientific applications. In classrooms and research labs alike, isotopes open portals to understanding time and decay. Although isotopes may appear similar at first glance, common misconceptions often confuse them with entirely different elements. This misunderstanding can cause puzzlement in high school chemistry courses. We resolve this by focusing on concrete examples. While both carbon-12 and carbon-14 are carbon, the extra neutrons in carbon-14 lead to measurable changes in mass and radioactivity. Science relies on these precise differences to unlock age-old mysteries hidden in archaeological sites and ancient fossils. Curious minds discover that even the smallest changes impact phenomena on a grand scale. Next, we transition to allotropes, another fascinating phenomenon. Allotropes are distinct structural forms of the same element. Their atoms bond in different arrangements, creating diverse physical properties. Carbon provides an exemplary case with its allotropes, diamond and graphite. In diamond, carbon atoms join in a rigid tetrahedral network that results in an exceptionally hard substance, prized in cutting tools and jewelry. Conversely, graphite features layers of carbon atoms arranged in a hexagonal lattice. These layers slide easily over one another, making graphite soft and ideal for pencils or lubricants. Chemistry thus reveals that structure is as vital as composition. The differences between diamond and graphite reinforce the lesson that not all forms of an element behave identically. Despite sharing carbon as their sole building block, diamond resists electricity, while graphite effortlessly conducts it due to delocalized electrons in its layers. This contrast provides an inspiring lesson for scientists and engineers, as each allotrope finds unique applications in various fields. From nuclear chemistry to advanced materials science, our grasp of these phenomena drives innovation in technology and industry. As we progress, consider how each concept builds on the last. First, atoms create a universal foundation for chemistry. Then, isotopes demonstrate that even slight variations can produce radically different behaviors. Allotropes further challenge our assumptions by revealing that the way atoms bond alters properties in dramatic ways. This step-by-step journey clarifies complex ideas through practical and clear examples. Fundamental principles are the keys to unraveling intricate scientific puzzles. Now, reflect on a common classroom challenge, connecting abstract concepts with tangible examples. By focusing on carbon-12, carbon-14, diamond, and graphite, we bridge theory and application. Visual aids, such as molecular diagrams and structural comparisons, support this learning process. These illustrations bring clarity, engaging students with precise imagery that transforms doubt into understanding. Science becomes a vivid narrative of discovery and exploration. In conclusion, today we have explored the dynamic world of isotopes and allotropes. We witnessed how minor changes in atomic structure foster significant differences in behavior and application. This journey underlines that in chemistry, as in life, small variations can lead to powerful outcomes. Keep questioning, keep exploring. Understand that every atom has a tale, every structure a secret waiting to be revealed. Explore the power of atoms in our extraordinary world.